Hello, my name is Shauna Ganju, and today I will be demonstrating how changing the initial spring potential energy changes the amount of increase of gravitational potential energy in a system consisting of this cart and the Earth. To do so, I will set this cart to 3 different spring compression distances and measure the height for each time. So as you can see from my results, when the spring was compressed to 1 unit, the cart displaced 0.205 meters. The angle was kept constant at 2.5 degrees. The height to which it went to was 9 times 10 to the power of negative 3 meters. So the way I was able to calculate my height was by using the trigonometric relationship between height, displacement, and the angle, as you can see here. So when the spring was compressed to level 2, the displacement was 0.9 meters and the angle was kept constant at 2.5 degrees. The height this time was 39 times 10 to the power of negative 3 meters, and I arrived at that answer using the same trigonometric relationship. So for spring compression 3, when the spring was compressed to 3 units, it displaced 2 meters at the x direction and the angle was still kept constant at 2.5 degrees. For this situation, the height was 87 times 10 to the power of negative 3 meters, and I was able to use the same trigonometric relationship to arrive at that answer. So in order to better represent my data, I created a graphical representation and plotted a few points of the height and compression distance. As you can see, when I plot height on the y-axis and compression distance on the x-axis, the graph has more of a square relation than a linear relation. However, whenever I change the compression distance on the x-axis to compression distance squared, the data actually becomes linear. So what this shows is that height and compression distance height is proportional to compression distance squared, which is the answer to the driving question.
For the ELA component of my project, I have decided to write a narrative essay describing my personal observations and experiences with the conservation of energy. Specifically, I describe the presence of the conservation of energy while I played sports in order to emphasize how the conservation of energy is an important aspect of our daily lives. Furthermore, throughout my narrative essay, I explained how the conservation of energy is incorporated in other physics concepts as well, which helped me gain a better understanding of physics in general. Overall, this PBL experiment made me recognize the importance of the conservation of energy, ranging from simply playing sports to constructing efficient modes of transport. For the social studies connection in my PBL project, I've decided to write a brief history of the conservation of energy. It was interesting to learn that the concept of the conservation of energy dates back to 550 BCE. Ancient philosophers viewed the idea of the conservation of energy very differently, but developments made by physicists such as Galileo and Newton refined the law over time. I also explained how various physicists contributed to the conservation of energy by conducting their own experiments in order to eventually consolidate the universal truth that energy can never be created nor destroyed, only converted into other forms of energy.